We're looking at the idea of moment of inertia in this section of video. The first thing is, what is inertia? Inertia has to do with no change. That's the basic meaning. But in physics, we look at inertia as something if an object is already moving with a particular velocity in a particular direction. So basically particular magnitude of speed and direction. It will not change until and unless an external force acts on it. That's the law of inertia, right? Similarly, similar to what we saw when it comes to your inertia with your normal linear motion, we have something to do with rotational as well. It's quite simple actually. See, if I have an object and say this is the axis of rotation, basically if I have to rotate it, if I have to make it start to rotate, I need to put some effort. If it's already rotating, to make it stop, I have to put some effort. So if there is no rotation, I have to put some effort. If there is some rotation and I want to change it, what should I do? I should put some effort. The change can be increase in the rotation or decrease at which an object is rotating. So for all of this, there is some effort that we have to put. So this too is related to your idea of inertia. How if we have an object which is not moving, okay, with some mass m, if it's not moving, we need to put effort to make it start moving, and once it's moving, we need to put some effort to change the status of motion. Similarly, we have stuff over here. If something is rotating, then well and good. If I want to change how much or what pace it's rotating, then I have to put some effort. If it's not rotating, then I have to put some effort. If it's already rotating, but if I want to make it stop, I have to put some effort. So here too, the idea continues. Even in rotational world, it makes sense, right? So energy cannot be created nor destroyed. So here the word or the phrase that we use is moment of inertia. So the basic idea, let's see what I have typed over here. Mass is how much something resists being moved in a straight line. Moment of inertia is how much something resists being made to spin. What is the physical significance? Physical significance means how does it relate to the physical world? Again, whatever I explained, that is it. So let's see what is typed over here. Physical significance, moment of inertia can be regarded as rotational inertia of the body. Rotational inertia of the body. It's easier to rotate things with one axis than, okay, this I won't be able to explain now. So I'll be doing it in the next video actually. So definition also, I'll come back to this once we have the mathematical. The sequence is a bit off actually. Okay, first question. So I have a video for you guys and you need to figure out which has more velocity. The outer one or the inner one. So let me show the video what it means. So question is, which has more velocity? Not angular, linear. Which has more speed? Let me put it this way. Which has more speed? Yes, the outer one, right? Now, a follow-up question is, which has more kinetic energy? So let's recall kinetic energy. We need kinetic energy over here. So kinetic energy is half, correct, mv, right? No, v square. So it's half mv square. Basically, higher the velocity, more the kinetic energy. So which one has more kinetic energy? The outer one, right? So this we need, and one more question actually you need to answer. You need to pause and figure it out. So let me go to the diagram which helps us with this. So let me consider an object. Let's consider the rotation, axis of rotation to be something like this. say we have one point A and another point B. Actually, that question is incomplete. With respect to these two positions, you need to answer this following set of questions. So which particle A or B has of the rigid body? Remember, this is a rigid body and the definition you have to remember. So do they have same or different angular velocity? The answer is same. Do you guys agree? So when something rotates for rigid object, for example, consider this to be a rigid object, a black color rigid object, which has a inner boundary painted with blue and the outer boundary painted with red. Right, that being the case, so can you answer this? Right, so they have the same angular velocity. Do they have the same linear velocity? No, right? They have different linear velocity. Do they have different or same kinetic energy? And this too I have answered. They have different kinetic energy. Now, to find the total kinetic energy of a rigid object, what should we do? We need to add up the kinetic energy of all the particles to find the kinetic energy of the body as a whole. Do you guys agree? If I am looking at finding out the kinetic energy of this particular rotating object, consider there are many points particle that object is made up of. If I have to figure out the total kinetic energy, I have to pick up each and add them up. So basically what we're looking at is the kinetic energy of the object which is just rotating. I can figure it out, say a single particle, I can figure it out with half mp square. But we have to figure out all of them. So it is summation of, you guys agree? It's a summation of all the particles and this would be it. And now we have to relate it to things being rotating. So we'll substitute V as omega r. And so we have half mi omega ri square. So question is, should I write a subscript over here or not? Answer is no. Why? Because all of the particle in a rigid object will have the same angular velocity. So there's no subscript. Omega is constant for all of them. What is this r? R is the distance from axis of rotation to the points. Since they have different radius, right? As a whole, of course, every few particles have r to be the same. So I'll not go to that, but you guys understand this, right? And so if I rearrange this, I'll get a familiar formula. Half mi ri square times omega square. And this looks like what? Half m v square. And this acts like your inertial aspect of the body. And that is your moment of inertia. And now let's go to the definition. Okay, I just rearranged and this is in the form of half mv square. So when you compare half mv square and this, so this has to act like the remember mass, sorry, I forgot to talk about this. Mass, I hope you guys remember. Mass, another way of defining mass is using the concept of inertia. More the mass, more the inertia. Right? So that's why we started off with the idea of inertia at the start. And the name also linked to this is moment of inertia. So let's go to the definition. Moment of inertia is the property of a rotating object that quantifies its resistance to changes in angular motion. Specifically, it is the sum of the product of mass of each particle in the object and the square of its distance from the axis of rotation. Okay, so whatever formula we saw, that's written over here. Right? So if I happen to show you guys this, half omega square is, half omega square is the constant. So I need not bother with that. The rest of it is your mi ri square. And this is your moment of inertia. Okay. So this is what the definition is talking about. So there is a lot to it. Understand the basic idea. Then the concept is Actually quite simple, as you could see. That's the concept. The derivation, yeah, it might take some time for you guys to get used to, but it's okay. It's not that hard. We'll make it easy.